Hello everyone. In this video, I'm going to talk about linear functions. I will explain what a linear function is, how to graph it, how to calculate the slope of a linear function, in what forms a linear function is expressed, how to express vertical and horizontal lines, and finally, I will do some exercises on linear functions and their applications. So let us start. We start with the definition. A linear function is simply a function whose graph is a straight line. Algebraically speaking, the terms of a linear function are either a constant or a single variable whose exponent is equal to 1, as you can see in the examples of functions in blue. However, the other functions in red are not linear because, for example, in the first function you have a term whose exponent is 2. In the second function, you have square root of x, so that's x to the power of half. And in the third example, you have 3 over x, which is 3 times x to the negative 1. Now, how do we graph a linear function? We said that a linear function is represented by a straight line. The easiest way to graph a linear function or a straight line is just to plot any 2 points on the straight line and then join them. Let me show you an example. Let us consider y equal to 2x minus 1. In order to sketch this line, we pick any 2 points, and it's always easiest to pick the intercepts. In other words, we first let x equal to 0 and find the corresponding value of y. Then we let y equal to 0 and find the corresponding value of x. So if x is equal to 0, which means if I plug in 0 into this x, I will end up with y equal to negative 1. On the other hand, if y is equal to 0, I end up with x equal to 1 over 2. So we have 2 points, 0, negative 1, it's here, as well as half 0, it is here. We join these 2 points and we end up with a straight line whose equation is y equals to 2x minus 1. Let us move on to the slope of a straight line. It is called the slope or the gradient of a straight line. It simply measures the steepness of a straight line. The steeper the straight line, the larger the slope. So if we have a straight line, the closer it gets to the vertical, the larger the slope. And the closer it gets to the horizontal, the smaller the slope. For example, if we look at these 4 straight lines, the green straight line is the closest to the horizontal, which means it's the least steep straight line here. And the red straight line is the closest to the vertical axis, which means it has the highest slope and the steepest. So as you can see, if you keep going towards the vertical, the slope keeps increasing. That's another example. Here the lines are going down, which means the slopes are negative. Again, as the line gets closer to the vertical, it becomes more steep and the slope becomes more negative. Let us come back to the definition. The slope measures the change of the dependent variable with respect to the independent variable. What does this mean? Let us see. Let us consider this straight line. And our goal here is to find out how to calculate the slope or the gradient of this straight line. Let us label any 2 points on this line. Let us suppose that the first point has coordinates x1, y1, and the second point has coordinates x2, y2. This means that this distance is the change in x, which is x2 minus x1, or delta x. So delta x is equal to x2 minus x1. This distance, on the other hand, is the change in y, so it is delta y. So delta y is equal to y2 minus y1. In our case here, y is the dependent variable and x is the independent variable. The dependent variable is represented on the vertical axis, and the independent variable is represented on the horizontal axis, which is x. Thus, the slope, which is usually denoted by m, is equal to the change of y, which is delta y, over the change of x, which is delta x. Or in other words, it's y2 minus y1 over x2 minus x1. We can also think of it as follows. The horizontal change is called the run, and the vertical change is called the rise. Therefore, we can say that the slope is equal to the rise over the run. Now, what about the forms of a linear function, or in other words, the forms of the equation of a straight line? The first is the standard form, which looks like y equals to mx plus b. As we said, m is the slope and b is the y-intercept. So if we have a straight line, the point of intersection of this line and the vertical axis is the y-intercept, which is equal to b. This means that if a line passes through the origin, b is equal to 0. So the standard form of this line is y equals to mx plus 0, which is equal to mx. The other form of the equation of a straight line is the general form, ax plus by plus c is equal to 0. In order to find the slope of a straight line that is represented in the general form, of course we cannot say that it's a, because in order to find the slope, we must have the line represented in the standard form, I mean y equals to some m times x plus b. Thus, in order to find the slope, we must isolate the y first. So this becomes by is equal to negative ax minus c. Then we divide all the terms by b in order to isolate the y. So we get y equals to negative a over b times x minus c over b. This means that the slope is negative a over b and the y-intercept is negative capital C over capital B. Let's do an example. Let's say we have 2x plus 3y minus 5 is equal to 0. So either I convert this line into the standard form, or I can find capital A, which is 2, capital B, which is 3, and capital C, which is negative 5. This means that the slope is negative a over b, which is negative 2 over 3, and the y-intercept, which is little b, is equal to negative c, that's a negative 5 over 3, and it's 5 over 3. The third form an equation of a straight line can be expressed in is called the point-slope form, and x0, y0 is just any point on the line, and m is obviously the slope. Let's do an example. Let's assume that the slope is negative 2 and the point is negative 1 and 5, for example. So this is our x0 and this is our y0. The line becomes y minus y0, that is 5, is equal to m, which is negative 2, into x minus x0, that is a negative 1. We get y minus 5 is equal to negative 2x minus 2, and you get the standard form. Now, since we're talking about a straight line, this means it might possibly be vertical or horizontal. Let us start with the horizontal line, and let's consider this example. And let us assume that this line intersects the vertical axis at some b. If we pick this point, it will have coordinates some x0 and b. Let's pick another point. It'll have coordinates some x1 and b again. What about this point? Some x2 and b again, so on. So no matter which point I choose on this line, I will always end up with y equals to b. And this is exactly what the equation of the line is. Y equals to b. It is like we are saying that this line has the feature that all the points on it have y equal to b. What about the domain of this function? It is all real numbers. What about the range of this function? As we said, we only have one output value, which is b. Let us now move on to the vertical lines. We assume that this vertical line intersects the x-axis at some a. And again, if we choose any point here on the line, we notice that all these points will have the same abscissa x equals to a, which means the equation of this straight line is x equals to a. But it's very important to notice that a vertical line is not a function. Why? Because we have an input value which has more than one output values. Actually, it has an infinite number of output values. So of course, it is not a function, it is just a relation. One more property of linear functions, then we do some exercises. We start with parallel lines. So parallel lines have the same slope, and this is an example. You can see that both slopes are 3. So once the slopes are equal, we say that the corresponding lines are parallel. On the other hand, two lines are perpendicular if their slopes are both reciprocals and opposite. This means that if the first slope is a over b, then the second slope will be negative b over a. So the first slope has sign positive, it becomes negative, so opposite signs, and obviously a over b and b over a are reciprocals. And this is an example. So m1 is equal to plus 2 over 3, and m2 is negative 3 over 2. That's all regarding the explanation. Let us do some questions now. In exercise 1, we are supposed to find an equation of a straight line which passes through 2 points. Since I'm given 2 points, I can think of the coordinates of the first point as x1 and y1, and those of the second point as x2 and y2. Let us use the standard form, which is y equal to mx plus b. Since we have 2 points, we can immediately calculate m, that is y2 minus y1, over x2 minus x1. So it is equal to 5 minus 1 over 3 minus 2, and that is equal to 4. So we get that y equals to 4x plus b. How to find b? We choose any of these 2 points and plug it into the equation. Let us choose 2, 1 for example. So y is equal to 1 equals to 4 times x is 2 in this case. This means that b is equal to negative 7. Therefore, the equation of the line is y equals to 4x minus 7. In question number 2, we are given a point, but we are also given that the line we are supposed to find its equation is parallel to this line. 2 lines are parallel means they have the same slope. So in order to find the slope of our line, all we have to do is to find the slope of this given straight line. In order to find the slope, we have to isolate the y. We keep the y term on one side and move everything to the other side. Then we divide everything by 2, and we end up with y equals to negative 2x plus 5 over 2, which means the slope is equal to negative 2. So y is equal to negative 2x plus b. How to find b? Again, we plug in this point into the line, and we get the value of b. So y is 3, x is negative 1, therefore b is equal to 1. Therefore, the equation of our straight line is y equals to negative 2x plus 1. In exercise number 3, we have to find an equation of a straight line that is perpendicular to this line. Thus, in order to find the slope, we have to find the slope of this straight line, then do the reciprocal and opposite. So 3x plus y is equal to 1. We isolate the y. The slope of this straight line is negative 3, or we can think of it as negative 3 over 1, which means m, which is the slope of the straight line we're looking for, will be plus and 1 over 3. So y is equal to 1 over 3x plus b. How to find b? Same scenario again. We plug in this point into the line and we get b. And this is our straight line. Let us move on to exercise number 4. We have to find the linear function before we proceed. Since it's linear, we know that it's f of x equals to mx plus b. We are given that f of negative 6 is equal to minus 1, and f of minus 2 is equal to negative 5. f of negative 6 equals to negative 1 means that if I replace x by negative 6, I will get minus 1. So, negative 1 is equal to m into negative 6 plus b, which is negative 6m plus b. Similarly, f of minus 2 is equal to negative 5, which means minus 5 is equal to negative 2m plus b. We've got a system of 2 equations with 2 unknowns. We can solve it in several ways. What we can do is the following. We can find b in the first equation, that's 6m minus 1, as well as in the second equation, so b is equal to 2m minus 5. And since b is equal to itself, then we get 6m minus 1 is equal to 2m minus 5, which means m is equal to minus 1. So our function now is f of x equals to negative 1x plus b. How to find b? We choose any of these 2 given information. Let's go with f of minus 2 is equal to minus 5. So minus into negative 2 plus b is equal to minus 5, and b is equal to negative 7. Therefore, we've got our function that is f of x is equal to negative x minus 7. We now move on to exercise 5, which is a word problem, a real-life application on linear functions. A taxi cab ride costs $3.5, and for each kilometer, it costs an additional $1.5. So first of all, one has to pay $3.5, and then for every 1 kilometer traveled by the car, we have to pay an additional $1.5. Let x be the distance traveled by the taxi cab, of course in kilometers, and c of x be the cost of taking a taxi for a distance x kilometers. So when the car travels x kilometers, I have to pay c of x. What is the question? Determine how much it will cost if the distance traveled is 10 kilometers. Before we determine how much it's gonna cost for traveling 10 kilometers, we first need to find an expression of c of x. So first of all, once I take this taxi cab, I have to pay $3.5. For the first kilometer, I have to pay an additional $1.5. Let's say I traveled 2 kilometers, so this becomes 3.5 plus 1.5 times 2. What about 3 kilometers? It'll be 3.5 plus 1.5 times 3. And so on. So this means that if I travel x kilometers, I must pay 3.5 plus 1.5 times x. And that's the expression of c of x. And as you can see, it is a linear function. So we conclude that c of x is equal to 3.5 plus 1.5x. Now we can answer the question. In order to find how much it costs for traveling 10 kilometers, all I have to do is plug in 10 into the x and problem solved. So c of 10 is equal to 3.5 plus 1.5 times 10, and you get $18.5. So this is the total cost if the distance traveled is 10 kilometers. One more question. A printing company quotes the prices of $1,400 for producing 100 copies of a report and $3,000 for producing 500 copies. Assuming a linear relation. Since we are told that it is a linear relation, this means we can immediately say that this situation can be modeled by the linear function y equals to mx plus b. What is the question? What would be the price of producing 300 copies? Again, as the previous question, first of all, we need to find an expression for this linear relation, and then the question becomes straightforward. Let us assume that P is the price of producing X copies of the report, so P is equal to mx plus b, and our first task is to find m and b. The first information tells us if x is equal to 100, then p is equal to 1400. So 1400 is equal to m times 100 plus b. The second information tells us that if x is equal to 500, then p is equal to 3000. So 3000 is equal to m times 500 plus b. And we've ended up with the system again. We follow the same procedure as we did in a previous exercise. So we isolate b in both equations, and then we solve the system. And we get the key equation. Now all we have to do is to replace x by 300 in order to get the price for producing 300 copies. So for x is equal to 300, p is 4 times 300 plus 1000, and we get 2200, and that's the price for producing 300 copies. That's everything on linear functions. The next video will be on quadratic functions. Thanks for watching, and see you in the next video.